So we have these two equations, ax plus 3y equals 25 and 4x plus y equals 19. These are called simultaneous linear equations and they are pretty easy to solve. In fact, they are so easy that there are 3 different ways to go about them. You can solve them through graphing, substitution, and elimination. For graphing, all you have to do is to determine the function for each equation and plot them on a Cartesian plane. Where the graphs cross is the point of intersection, aka the solution. In the case of substitution, just grab one of the equations and isolate for a variable. I like to call this the nickname of the variable. This is because it is still equal but just written in a different format. Kind of like how a nickname is spelled differently than a name but still refers to the same person. Now, all you gotta do is grab that nickname and replace it with all the instances of the variable within the other equation. Now that you have only one unknown variable, you can figure out the answer accordingly. Finally, the fun one, elimination. First, you put the equations in a way almost like how you would do if you want to add or subtract. Now you multiply the coefficients by a factor that would cancel one of the variables. In this case, I can multiply the bottom one by 2. Since I have ax in both of my equations, I'll subtract them to cancel it out. Ax minus ax equals 0, 3y minus 2y is just y, and 25 minus 38 is negative 13. Now that I know that y equals negative 13, I can plug it back into either one of my original equations and solve for x. There we have it. X equals 8 and y equals negative 13.